Hello everyone. In today's class, let us understand about transformer, its working, and its constructional features. What is a transformer? Basically, you would have come across a transformer while moving around near the house. During an industrial visits also you would have seen the transformers. Also I have shown you the transformers prototypes. So basically what is a transformer? A transformer is a static device, that means to say there are no moving parts, and which transforms electrical energy from one circuit to other circuit without any direct electrical connection, and also without change in frequency. That means the frequency must remain same or constant through the process of electromagnetic induction. Now let us understand why the transformer is necessary. What is the use of the transformer? Generally, as we define the transformer, the necessity of the transformer, basically the principle of operation of the transformer works on the electromagnetic induction. Why we require transformer means, when you see the generations takes place at higher voltages and it has to be transferred to the domestic and industrial purpose at the lower voltage levels. So the transformer is a device wherein voltages may be stepped up, increased, stepped down, decreased, and the one more major advantage of is it works on the AC supply. Also, transformer is the only device practically wherein we will be able to achieve 97 to 98% efficiency, as it has no moving parts. Also, transformer is associated with low power applications. Now, let us understand about principle of operation of a transformer. As we all know, transformer works on principle of electromagnetic induction and mutual induction. Now, observe the circuit here. In a circuit, when an alternating voltage V1, you can see in the left side, is applied to a coil. Coil is N1. It has number of turns in the primary winding, and by applying this, we will produce an EMF E1, and which is induced across the coil N1. Now this E1 is called self-induced EMF. Why? Because it is induced across the first coil itself. Because of this, an alternating current I1 which flows through the primary winding, as you can see here, here I1 flows through the primary winding, which sets up an alternating flux phi, as mentioned here, flux phi in the core, and the equation for phi can be given as phi is equal to phi m sin of omega t, and the unit for flux is vapors. Now due to this flux which is linking with secondary winding, that is number of turns on the secondary, so this flux linkage even gets induced as well as induced EMF in the secondary winding, that is E2, as you can see in the diagram, which is called as mutually induced EMF. Now the induced EMFs E1 and E2 are as per the Faraday's laws of electromagnetic induction, and we can represent them as E1 is equal to minus N1 into d phi by dt, and E2 is equal to minus N2 into d phi by dt. Now where the turns N1 and N2 are the number of turns on the primary and the secondary respectively. Now the RMS values are generally represented as E1 and E2. Here E1 is proportional to N1 and E2 is directly proportional to N2. So we can write the equation as E1 by E2 is equal to N1 by N2, or E2 by E1 is equal to N2 by N1 is equal to K. K is called as transformation ratio. Now based on the construction of the transformer, there are two types of transformer we can define. One is core type transformer, the other one is shell type transformer. And based on the number of phases, we have single phase transformer and three phase transformer. Also based on the location of the transformer in the power station, we have power transformers and distribution transformers. And based on the high voltage levels, we have HV, that is high voltage, and LV transformers. And based on transformation ratio, we have step up transformers and step down transformers, and also 1:1 transformers. Okay, you can observe here there are two types of transformer. One is core transformer and the shell transformer. Two types of transformers are core and shell. Now in core, is rectangular in shape and it has generally two limbs as you can observe in the diagram. Here both LV and HV coils are placed on both the limbs, and the coils which are used are cylindrical in type, and the windings are encircled the core, and the core is made up of large number of thin laminations. Generally it is used for HV, that is power transformer. And when it comes to shell type transformer, you can observe here from the shell type transformer. Here the core has three limbs as you can observe here. Both the windings are placed on the center limb itself. So it has double magnetic circuit, and here the core encircles most part of the windings. Here the coils are used are multi-layer disc type, and these types of transformers are generally used for LV transformer. So this is about core and shell and also the definition of the transformer. Thank you.